transformation y equals a f of x. We have looked at graph transformations with various graphs before. We are now in a position to look at these transformations applied to trigonometric graphs. So if we think about y is equal to a f of x, so here we have the graph of y is equal to a sine x, where at the moment we can see here from the constant controller the value of a is 1. So this is just y equals sine x, the standard sine graph, which has a maximum value of 1 and a minimum value of negative 1. And we can see one complete oscillation here, another one here, and we know it goes off to infinity just like this. So let's increase the value of a. So we don't want to do that, we don't want the step to be 1. So we'll increase a to 2, and now we can see the maximum is 2 and the minimum is negative 2. This is a vertical dilation, scale factor 2. So if we now go for 3, we can see the maximum is 3 and the minimum is negative 3. And you'd expect the same sort of thing to happen for 4, and so on. Notice, as we change the value, that the zeros are still the same. If we take a point actually on the x-axis, the distance from the x-axis is 0. So when you multiply that by anything, it stays 0. So the x-intercepts don't change. Let's go back to 1 so that we have the standard graph again. Now look carefully at this and then look what happens when we make a negative 1. Let's go back to 1 and you can see that again. Here's 1, here's negative 1, and we can see that's a reflection in the x-axis, and of course if a is negative 2, negative 3, then we get the vertical dilation combined with the reflection in the x-axis. Now here we have y equals a tan x. I'm not going to bother looking at the cosine because the cosine is exactly the same shape as the sine. It's just translated horizontally or phase shifted compared to the sine. But the tan is a different shape, so let's look at that. Well, key point on this one, there's no maxima or minima, but here, when this is pi by 4, the tangent of pi by 4 is 1. And note we've got a equals 1 here, so this is the standard graph. Now this key point is the one that's going to change. So if we make a 2, note at pi by 4 this has moved up to 2. At pi by 4 it's now moved up to 3, and so on. Over here at negative pi by 4 the original curve would have been at negative 1 and now it's at negative 3. So we can see this vertical stretching or dilation. Note the zeros never changed, and we've already discussed that. So if we make a negative, then we get that reflection, and note at pi by 4 this is now at negative 1, and so on. We get a stretch together with a reflection in the x-axis.